Okay, welcome to week, I think this is 11. Yeah, week 11 of Fundamentals to PLC. This week, a quick lecture, and then we'll get into the final individual project, which will be due, I've set midnight next Tuesday. So a full week to get that done. Yeah. So we're going to quickly cover today specifications. So the last few lectures we've gone through, we've covered electrical drawings, updating electrical drawings. So we have a good understanding of what is required to be inside of the drawings. We've covered process drawings. We have a good understanding of what needs to be inside the process drawings. I've noticed the submissions from last week for the group assignment, so I'll get marking those quickly. The last piece of any major project, whether it is a municipal project or a private project, there are going to be specifications. So I'm sure all of you have looked up specifications for any individual parts. Let's say you're looking to renovate your kitchen, you're looking to renovate your bathroom, you're looking to buy a new computer, you are going to look up and figure out what it is, the parts that you're going to need. Same thing for any of these projects, any major project, we're going to look at finding all of the parts that we want for the automation process. And what we do as a municipality, what you would do as an end user is you would create your drawings, which would your design, and your specifications, which would spell out everything that you would want as an end user. I share my screen here. Start. Share screen. So everyone can see this. Snow, maybe.
Yes.
Thank you. So this is an example of a project I worked on a number of years ago. So it's no longer active, and the warranty period's over. But this was for a wastewater plant upgrade. So there are many parts to the specs. So if you've ever worked on major projects, but maybe some of the electricians here, you've worked for a large construction project, half of the project management has to do with, is everything to spec? Is everybody following the contract? And the bid documents and the contract will all reference these specifications. So these specifications are very large documents. This one is this one's 151 pages. So it gets into granular detail of the examination of the place of work and spelling out where you're going to be working on a specific site, what you're going to be doing. Do you need to do environmental studies? How are those environmental studies going to be handled? How many meetings are you expected to hold? Who's supposed to hold those meetings? It goes on and on and on. We are going to focus for your project. We're going to focus on a specific division. Again, we're following the theme of we're working for the region of Cantor. And since we are doing PLCs, we're working on the automation equipment. We're going to focus on what would be called Division 13 or Division 16, depending on your contract, and that would focus on automation equipment. But just so that you're aware, these specifications would be put out towards what's called a tender. So for a municipality, the municipality will hire an engineering firm to do a design. Once the design of the project that they want is completed, they will put together a tender package. That tender package would be released to general contractors. Inside that tender package, there will be drawings, there will be specifications, and there will be a chance for questions. So a general contractor and other engineering firms, other contracting services will have a chance to review the specifications. They'll have a chance to review the design. If there are questions about clarifications for specific sections, those questions would be posed back to the municipality or back to the engineering firm or both, and then either answered in direct question answer format or addendums to the specifications would be made. So that being said, if you have this document, and I'm intentionally scrolling very quickly because we don't want to get hyper focused on bonding requirements and warranty period at this point. What you do want to look at here, again, bid forms. These specifications will have a lot of details on how to submit your bid, how to submit the bid and a price. Sometimes you have to make a submission without a price and with a price so that the bids can be evaluated in a specific way. It will even get into terms of how you will get paid if you are the winner, breakdowns of all the work. It's a documentation that spells out how the end user wants their drawings to be done, how the contract administrator shall provide baseline and benchmark information for the general location, alignment, and elevation of the work. So it's asking for, in very legalese terms, it's asking for elevation drawings. So when you're doing large projects, you have to spell out what you want. Just like if you're doing a small project at your house and you're bringing in a general contractor, you have to tell them exactly what you want to make sure that you're going to get the work that you want. These will be broken down into different divisions. So again, hundreds and hundreds of pages. I brought out division 16. So the electrical division for this project will have the general scope of work for the electrical portion. Sorry, I'm just admitting somebody. We'll have the electrical portion of the work for the project. Supply, installation and commissioning of one new substation of a specific size with a pad mounted tamper-proof transformer, primary incoming switches. Again, I'm skimming this intentionally just so you get a good understanding of what specifications are. Because if you get into, especially if you land in an engineering firm, even the engineering offices of manufacturing facilities, you will have the engineers and legal team working on project design specifications, and it's important to know what those are, especially when you're dealing with, you start getting into things like supply and installation and commissioning of new SCADA network, including the new control panels and several vendor supplied panels, the supply and commissioning of all instrumentation, the supply and commissioning of all lighting and receptacles. In this project, all of the design, all of the SCADA equipment has been grouped into division 16, which the standard for specifications is electrical equipment. So they're classifying that as electrical equipment for this project. Sometimes the automation equipment will end up in a different division depending on the design engineer. So very brief brief overview of what specs are. Are there questions about what you would expect to find inside a specification? Again, this is a very, very, very brief overview. Again, this is 163 pages of the electrical specification for a wastewater plant. And this was a large scope wastewater plant. It was brand new, 5 buildings, like multi-point. Has anybody worked with specifications before? Have you been involved with reviewing them, creating them? No? Yeah. So every engineering project is going to have a specification sheet. Almost every product is going to have a specification sheet. So one of the things I'm doing right now is the city of Guelph. We have multiple upgrades going on. When we receive back, remember the shop drawings with the electrical drawings that you guys submitted as a group, one of the things that I am doing is I am receiving shop drawings back on different devices. So we've put together a design with an engineering firm, and the general contractors coming back with flow meters, level transmitters, pumps, different types of pumps, different types of tubing, different types of hatches, flooring specifications, roof hatches, door contacts, all of that stuff. So all of those things have a clause inside. Let's see, doors. So all the outdoor MCC lighting, all of those things should have clauses inside the specifications. And it's somebody's job, so it's my job to review and make sure that at least the automation equipment for the PLCs is being supplied as per what has been specified. So in a project, if you're ever quoting a project, it's very likely that you're going to end up having to search through multi-hundred-page specifications and try to pull out things like this: operator controls and interlocks, and some details about the voltages of those, local remote switches for selection, manual control speed scales. So there could be very vague descriptions as to how everything needs to be specified. So if you're going to build an electrical control panel or a PLC control panel, you'll have to go and find the operator controls and interlock section and dig through the specifications and pull out all the pertinent information. Here's information on RTDs for measuring pump bearing measurements, temperature measurements, alarms and interlocks for the different subsystems, so that you can make sure that the product that you're going to quote and supply, or at least propose to supply, meets their specifications. So in a nutshell, this is the design, and this will end up being a contractual document when it comes to once you've been awarded the work. All of your work will be held against the specification. So it will become, for lack of a better word right now, the bare minimum of what needs to be supplied. There may be addendums to the specification if errors are found. Oh. Sorry, I think somebody's stuck out of the. No. It just wanted me to sign in. I'm sorry, that interrupted us. Okay, so yeah, there's way too much to cover inside these specs. You just need to know how to look them up. When you're searching them, reading them from cover to cover is almost impossible. I can honestly say I've never read an entire spec cover to cover. I very much end up searching for the different sections that are going to be pertinent to my scope of work. Even in the engineering, like for the general engineering design, the civil guys will work in the civil sections and the mechanical guys will do the work for the mechanical sections, and they each might know their sections very well, but I would be shocked if somebody has ever read from start to finish some of these specs. The one we just put out for the major upgrade at the city, I think, was 1,700 pages. So a mind-numbing read. Any questions before I open up the specifications, the specific ones for the project? I do want to go over those ones. Oh, perfect. So for week 11, since there were some issues last time under individual project, can everyone, you might not be able to see that. And I see there. That should be visible now. And everybody should have access to these 4 documents. These are what I'm going to open up right now. So this is the PLC hardware specifications for the region of Cantor. Everyone can still see that. I just got a blurb that my internet connection was restored. I wonder if that was okay. So read through these specifications. They're 12 pages, but it's fairly well spaced. This is going to detail what we need to do for the project. So when required to submit documents, at a minimum, the following submittals must be made to the region: PLC hardware bill of materials and a PLC IO list. This general document provided by the region indicates the region's standards for the use of Allen Bradley ControlLogix programmable controllers within their water and wastewater facilities. This document provides the standards for hardware related to this family of controllers, including processors, IO cards, communication cards. The goal of this document is to ensure that the programmer selects PLC hardware that conforms to the region standards. Following these standards is the consultant's responsibility. Failure to follow these standards could result in rejection of the design. So this is again part of the standards documentation we've been talking about the last few weeks. In here, it's going to detail the ControlLogix, explain what they are, and then the requirements at the region of Cantor. So ControlLogix must use the IO specified below in this document. ControlLogix processors need to have a USB in the front, the lowest chassis possible, given enough free space for the processor communication cards, IO cards, and a mandatory spare for new PLC systems. So this is telling you the size of the rack that you need to use based on the number of cards that you have for the IO required, plus communication cards. Does that make sense? So we have an IO list as well, which we will cover. So there are disclaimers in here for IO points for process areas, size specific to this hardware specification document will change outside of CNTR 1340. If you are required to specify a PLC processor, please discuss with your client and or company when to use controllers with different amounts of memory. So this is kind of, this says this is for this project, this like inside this project. If you need to do specifications for your end users in the real world outside of this course, you'll want to talk to them and figure out what it is that they want to use. So this is, again, by no means a universal standard. This is a good example of a spec that you're going to find or a client of yours or your employer might already have. But don't use this as this is what the college says we have to do. This is set up specifically for use in this course. So depending on the different process area sizes here, up to 0 to 50 IO points. If it's SIL3 or SIL2, these are the processors that the region is calling for. For your Ethernet communication cards, these are the acceptable cards to use, depending on the application. Note that when two communication cards of different types are used in the same chassis, they can essentially act as a bridge between different networks. For example, the ControlLogix PLC can receive information over ControlNet and send that information to a different PLC over Ethernet IP. So if you install two different Ethernet cards or network cards in one rack, you can actually bridge networks. We're also going to specify the different IO cards that you're allowed to use for the region of Cantor inside these sheets. The chassis sizes that you're allowed to use based on the IO requirements. The rack layout and the preferred order of cards to be put in. So for a single rack installation, controller, communication card, discrete inputs, discrete outputs, analog inputs, analog outputs, specialty modules if applicable, and then one mandatory spare slot, and then any additional spare slots. If you require a second communication card, it goes in before the digital inputs. Here are some more examples of card layouts in the event that you need multiple racks. One of the controller, a communication card, and then a communication card for a network for the remote racks. If you require redundancy, there's redundant systems are only required when requested by the region. If it is not specified, let me just confirm that. So in this assignment, you will be designing a PLC system by specifying the hardware and IO placement capable of handling the specific requirements of the region of Cantor. You will be given process drawings, which are here, and they're available online. Design requirements. So those are the design specifications that we were just going over, and an IO list. Sorry. There's a blank IO list which you need to fill in with the part numbers and the descriptions for all the different IO. So based on the IO that you'll find in your process drawings, you'll need to build an IO list. So figure out what inputs and outputs that you need. You'll need to pick your cards Then you'll need to pick your processor and your rack, and then submit that. So the PLC designs will have the correct modules to receive all the inputs, have the correct modules to send all the outputs, follow the design requirements from the region of Cantor hardware specifications, follow the design requirements. Oh, that duplicates it. Yeah. Again, when looking through the specifications, Control F is a shortcut to try to find information. So if you want to find card part numbers, 1756 dash something are going to be your control logics parts. So if you search for those, you'd be able to jump through. These specifications are only 12 pages long, so it might not save you too much time. So directions: follow the instructions below to complete your assignment, and remember to start your assignment early, so you can direct any questions to me as soon as possible. The region has requested a new PLC rack be designed for their HVAC system. The process control narrative of the HVAC system as follows. Water is heated through a boiler. Resultant hot water is pumped to a three-way analog valve that mixes a percentage of cold water to achieve a desired discharge water temperature of 70 degrees C. The resultant 70 degrees C water is sent to the blower room to heat up air traveling through blowers. Current installation requirements demand for one blower. A second blower is planned to be installed in the future. Blower 1 pushes hot air through the building to keep the indoor temperatures at a minimum of 12 degrees C during the winter. Motorized dampers are placed at blower 1's intake and discharge. The HVAC system is a Category 2 safety area, SIL2. So if there are any safety requirements detailed in the specifications, SIL 1, 2, or 3, you'll have to design as required. All control wiring, DI, DO, in station is 120 volts AC. So make sure you pick the right card voltages. Control logics is to be used, not compact logics. Okay, it says here, use optional or alternative modules if possible to save on costs. Provide at least 2 spare slots. Complete parts A, then B, then C, then D, then parts E. So calculate your number of IO that you require. So that will be found on the PDF drawings. You'll have to look through the P&ID drawings to figure out your digital inputs, outputs, analog ins, analog outs, and then calculate how many digital cards you're going to need. So how many DI you have, how many points are on a DI card, etc. It gives you a calculation here. Then you'll need to place your modules on your IO list. There's a blank IO list for you to use. All of the information, the module part numbers, if they're right, that's by coincidence. So make sure that you make those changes and line them up for all your DIs and DOs. Put your descriptions in. And if there's any tag information that you're able to get or create, add that in as well. Add the IO from your P&ID to the IO list, and then submit your IO list for marking. Are there any questions? Does everybody have access to those files I pointed out in D2L? How about Does anybody not have access to those in D2L? Wonderful. That's all I have for a lecture, guys. Oh, somebody's on.
Sorry. Hey, Ryan.
Hi.
Quick question, Snaddy. So for part 8, is it fair to assume that the drawings that were provided, the PDF, similar to like the previous assignments, is it fair to assume that the PDF provided is accurate, and then we have to complete parts A to
Yes.
D based on that?
Yep. Build your IO list based on these PDF drawings. So read these P&IDs, both of them, figure out all the IO. Once you've counted up and separated your IO, make your IO lists. And then once you have your IO list, then pick your cards. Does that make sense?
Yeah.
So this is the order of designing any station that I've done in the last 16 years. Figure out we're normally given, these are the devices that we want to install. We have to figure out what IO can be wired, is required for that. And then once you know your IO list, you can literally count up what you need, pick all the cards that you require. Once you have all the cards you require, pick your processor, build your rack. Then you would build your terminal, and then beyond that, so that's where we're going to stop with this assignment. But then beyond that, you have to then put all the terminal blocks inside of your panel. You have to design your back plane. You have to pick a size for your panel. You've got to try to fill it all up. If the back plane's too full, you have to pick a bigger panel and redesign. Yeah, this is the beginnings of the design process for a panel, then software, then entire plants.
And second question I had is for the bill of material itself, the costing for the bill of material. Is it okay if we reference to one of the older assignments? I think this was in week 5, where there was some costing provided for some of the devices, or are we expected to just look online and then put the pricing in?
Sorry.
Oh, it's actually refers to week 5. Okay, never mind. It does refer to week 5.
I just wanted, I was pretty sure I read that. I just wanted to find it for you. Great questions. Thank you. Anybody else? Perfect. If you guys have any questions, I'll be around. I'm gonna go finish my dinner, and I'll be at my computer most of the time going through what you guys submitted and some quizzes. So just mic in or send me a message in the chat and I'll get back to you as soon as I can. I'll probably be away for like 5 minutes while you guys get started.